Start?
Yes.
Perfect. So first of all, thanks to Marcos for inviting me to this. It's actually not the first time. I think we're about to make it a tradition, right?
Yeah,
so
yeah,
three
yeah.
times count as the start of a tradition, maybe. My name is Joas. I'm trained as a physicist. I have a PhD in physics, actually condensed matter physics, but then I switched to history of science. So for the last about 10 years, I've been a historian of physics, doing research on the history of quantum physics. And since 2017, I'm the director of the Niels Bohr Archive, which is a small institution here at the University of Copenhagen, keeping all the historical papers of Niels Bohr and his colleagues, and doing research into the history of physics, especially the history of quantum physics, nuclear physics, particle physics. What we're also doing is outreach in a broad sense, and this is part of sort of our outreach effort. We want to tell people in the world, and especially all the bright physicists who are coming here, about Niels Bohr and the history of this place. I've prepared way too many slides. The title of my talk is The Copenhagen Spirit, a history of the Niels Bohr Institute. I, on purpose, didn't call it the history of the Niels Bohr Institute because there's many, many good histories that have already been written. I'm sort of perusing them in my talk. So very little of this, especially in the beginning of the talk, is my own research. A little bit towards the end, you'll get a peek into my own research, if we even get there, because I don't know exactly how much time we'll spend on this, but we have like 30, 40 minutes. I think that's... Yeah. Okay, perfect. So let's get started. I start with some basics, which you might be familiar with, but anyway, quantum theory, probably you've heard about the famous paper by Max Planck in 1900. It emerged from 1900 within a network of only a handful of institutions, which are plotted here on this map. And if you now center in on quantum mechanics, which came about in the years 1925, 26, 1927, that happened at an even more exclusive selection between these places, namely, first and foremost in Göttingen, Copenhagen, and in Munich. Those were the three places, and then soon Cambridge, for instance, would join with Paul Dirac. There were three main father figures at these places. It was Arnold Sommerfeld in Munich, Max Born in Göttingen, and Niels Bohr here in Copenhagen, and they would sort of freely in the 1920s exchange bright students. Think of Werner Heisenberg, Wolfgang Pauli, Henrik Kramers, and many, many others. Like no other place in the world, Copenhagen is sort of connected to this legacy for creating quantum mechanics and actually for interpreting quantum mechanics. You all have heard of the Copenhagen interpretation of quantum mechanics, I'm sure. So it's not that often that something in physics actually gets a place name attached to it. That's the case in quantum mechanics for Copenhagen. These are the three parts of my talk. So the heyday of physics here in Copenhagen is certainly the part one between the two wars. That's where Copenhagen was the world center of physics, but it's still a very important place. And I'll also tell you about what happened during the German occupation in the 1940s. This is a good point to tell you that at any point you may interrupt me. If you have questions, this is just like your regular physics talk in a way. It's okay to doubt me, then you just shout and I'll hopefully notice. Perfect. Niels Bohr Institute between the world wars. Let's start by looking at Niels Bohr. He was born in 1885 and he died in 1962. This is Niels Bohr in 1916 when he had just become a professor here in Copenhagen. That was his very first professorship. He actually had a 10 square meter office at the Polytechnisk Lehranstalt, which is now the Natural History Museum, which he shared with his assistant Henrik Kramers. And then a mere 5 years later, this entire place was his. How did this come about? Well, let's start very early on in his life. His parents were Christian and Ellen Bohr, and he actually was born into a family that was used to their kids going to university already through several generations. His father was a famous physiologist. Actually, there's something called the Bohr effect on human respiration that he coined. He even was suggested for the Nobel Prize in Physiology twice, but didn't get it. So he came sort of from academic nobility, if you will. His younger brother Harald would become a mathematician, a renowned mathematician in his own right. Bohr, however, took an interest in physics and a little bit mathematics and chemistry. So in 1911, he wrote his PhD dissertation on what we nowadays would call solid-state physics. It was on electrons and metals. And already back then, he realized, okay, some of the things that appear in metals, in the electron gas in metals, actually cannot be explained using classical physics alone. But it's really, really complicated. You know about solid-state physics. There's tons of particles, 10 to the 23 particles. It's not the place to go look for a change in your fundamental theory. So that made him look at atoms as the best pathway towards changing something about classical physics. He also married, and that was quite important to him, Margrethe Nørlund. Now, this is the time for me to test this out. It's where, wow, that's electronic. That's Margrethe. She became really important to him and basically sort of the mother to his students, as he would put it. And so she was also important to all the foreign students who came here, because she sort of took care of their practical needs, hunting, I don't know, for the right rice for the people from Asia, for instance, because they couldn't get it here in Copenhagen in the 20s, or for specific chocolates that Americans missed while they were visiting here. After his PhD, Niels Bohr applied to the Carlsberg Foundation for a stay abroad. And I will now show you and read to you the entire application. This is it. The undersigned permits himself to ask for a travel grant of 2,500 crowns for a 1-year research stay at a foreign university. Honestly, sincerely, Niels Bohr. He sent that off on a Thursday afternoon. There were the mail came several times a day. And he got a reply on Friday at lunchtime, where they informed him that this was granted. So he didn't have to say where he was going. He didn't have to say what he was doing. That is how things went. They trusted him that he would do this the right way. Of course, it maybe might have helped that he basically was the only theoretical physicist in all of Denmark, right? At the time, he had just done his PhD. And that had been reported in the main newspaper, Politiken. So everybody knew about this strange thing that they now had a theoretical physicist. All right. He decided to go to England, not Germany, which would maybe have been the more natural choice for somebody from Denmark, and started to work with J.J. Thomson in Cambridge. They didn't really hit it off, so he soon moved to Manchester to work together with Ernest Rutherford. If you don't know those names, Thomson, you could say, is the discoverer of the electron. Rutherford, on the other hand, is the discoverer of the nucleus, the atomic nucleus. So not insignificant people when it comes to atomic physics. In 1913, he would write a trilogy, 3 papers in a row, called On the Constitution of Atoms and Molecules, in which he introduces the atomic model that you all are familiar with. I show you a very complicated version of that here. This is radium, according to the Bohr model. You're probably more familiar with the hydrogen atom. That's actually the very first depiction he has in a draft for that paper that he sent to Rutherford in 1912. So that's the very first time somebody has drawn the nucleus in the center and the electrons circling around it, like we all know it from the Bohr model. John Heilbronn, a famous historian of physics, once said Bohr would not have created his quantum atom if he had followed the standard course of Danish scientists and finished his training in Germany. That's important. There was a British tradition in atomic modeling that was inexistent in Germany. So had he done what all other Danes at the time did, namely just go to Germany, also because it was easier to pick up the language, and Germany was the bigger powerhouse in physics, he would not have come up with that. He went to Germany and actually had to interrupt his tour through Germany because of the outbreak of World War I. He went back to Manchester, and then I already told you that, became a professor here in Copenhagen in 1916. He could also have stayed in the UK, but he was determined to return to his home country and establish physics in his home country. In 1922, he would get a Nobel Prize. So now about this place that you're sitting in, already when he arrived here in 1916, efforts started to create an institute just for Niels Bohr, and it opened in 1921. Bohr was the director until his death in 1962. It was called University Institute for Theoretical Physics at first, and then since 1965, it's called the Niels Bohr Institute, so 3 years after his death. In the 20s, the central research topic was atomic physics, atomic structure, quantum theory, and there were numerous international staff members, guests, and students, also from Germany, often funded by the Rask Erste Fund, which gave tons of money to these visitors. And there was a combination in Bohr's efforts of an agenda for furthering Danish science and an internationalist agenda. So one thing that's independent of Bohr is that the neutrality during World War I of Denmark actually made Denmark into an ideal meeting place for physicists after the war, because German or Austrian physicists, they weren't allowed anymore in Great Britain or France. So they couldn't go to the big conferences in Great Britain or France, but they sort of were the most powerful theoretical physicists in the world. So you needed to create a place where people from all other countries could meet the Germans and the Austrians, and which better place than neutral Copenhagen. There's one other place that decided, which wasn't neutral during the war, but which decided, okay, we're also going to allow Germans, and that's Belgium. And you might have heard of the Solvay conferences, which is another sort of meeting point for international scientists. And so the other point is that both nationally and internationally, Bohr explicitly positions himself and repeatedly against the exclusion of these scientists from central power. So for instance, he gets asked whether he wants to become the president of the International Union for Physics and Applied Physics. And they had just started to adopt a rule not to invite any people from the central powers of World War I, so no Germans, no Austrians. And Bohr said, well, if you keep that rule, I'm not going to be your president. They kept the rule. He didn't become the president. So he was steadfast in his principles there. You might have noticed this university. Now it's, of course, not Universitätes Institute, but it says Niels Bohr Institute. This is the historical picture. See how it was all alone in front of the park, no other buildings connected to it. And it says 1920. Actually, it only opened in 1921. What's the reason for that? Well, there were economic troubles in Denmark after World War I, strikes by construction workers, the cost explosion, a huge inflation, and also like the currency with respect to the British pound and the US dollar went really down. So the building in the end became twice as expensive as estimated in 1917, and the equipment thrice. And you might have heard of a mythical building called the Niels Bohr building, which is about to be finished here in Copenhagen on Jagtvej. I don't know whether that became a topic. So, okay, yeah, you're living that mythical place. Okay, I actually also have a desk there. But so there are parallels between this story and the Niels Bohr building. Let me keep it at that. Here is a picture from the opening ceremony on the 3rd of March, 1921. Now I'm standing in exactly the same place that Niels Bohr is standing. And you're sitting in the place of these visitors, who actually almost exclusively were the people who had given him money or political support. They were not physicists. And the reason is that they had invited physicists 3 times in a row and then didn't open the institute. So in the end, when they invited for a 4th time, people didn't show up because they didn't expect it to happen that time. He's actually doing experiments. Everybody in the audience had been given a glass plate with a grid on it, and they had a platinum lamp standing there, and they were doing interference experiments with that grid. So what a nice parallel to what I caught of the last talk here that you gave. They looked at interference patterns. This is the audience, and there's like 2 important people you can see there. The one is the famous philosopher Harald Höfting, and the other one is Kirstine Meyer. You just barely can see her here. And that is one of 2 women who were the very first ones to finish a master's degree in physics in 1891 here in Denmark. The other one was Hannah Adler, Niels Bohr's maternal aunt. So 2 women came first in physics in Denmark. One of them was present there. The other one was Niels Bohr's aunt. This is from the speech that Niels Bohr gave on the 3rd of March, 1921. This institute is not intended solely for scientific research, but is also to be a homestead for the teaching of physicists. Summer school, right? It is therefore of the greatest significance not just to depend on the abilities and powers of a limited circle of researchers, but the task of having to introduce a constantly renewed number of younger people into the results and methods of science contributes in the highest degree to continually taking up questions for discussion from new sides. That's a very Bohrian sentence, just the length of it, and that I'm running out of breath reading it. It's very Bohr. I should like to express the hope that this institute may be a place where in the course of time, many young devotees of physical science may obtain guidance in their study and help to make their own contribution to the advancements of our understanding of nature and to the honor of Danish science. This is the original, rather international staff here, all the people who worked here in the beginning. And you have people from Hungary, like George de Hevesy. You have someone from Norway, Svein Rotteland, somebody from Germany, James Frank, somebody from the Netherlands, Hans Kramers. And then you have lab assistant Jacob Jacobsen from Denmark and a secretary, Betty Schultz, also from Denmark, and of course, Niels Bohr. In the newspaper article, the picture looks like this. So who's missing? The lab assistant and the secretary, the only woman on the picture. They weren't deemed relevant enough to appear in the newspaper. In the 20s, the Institute almost immediately expanded. So in 1924, they made more space for visitors. They also built this villa that you have seen, where you have this bronze panel in the mid-20s, which became the living quarters of the Bohr family back then. And the Institute became a central context for the genesis and further development of quantum mechanics. This is often referred to as Knabenphysik, young boys physics, because all of these people were like 22 years old, 23 years old, 24 years old when they developed quantum mechanics and made their main contributions, like Kramers, Klein, Heisenberg, Pauli, Jordan, Dirac, Rosenfeld. They were all really, really young. Oppenheimer could be added to that. Many people are thinking about Oppenheimer these days. Happy to answer questions about the relationship between Bohr and Oppenheimer. That's not a topic of my slides, at least not so far. It also became an important place for Soviet physicists, think Lev Landau or George Gamow, and other non-European physicists. And I include the Americans there, like Harold Urey, Frank Hoyt, John Slater, but also Yoshio Nishina, Yoshikatsu Sugiura, and so on. The US was a developing country physics-wise. There was no high-level theoretical physics in the US in the 1920s. That is something that only happened later, in large part due to the people who had stayed in Europe in the 1920s and 1930s. And the same could be said about China, India, Japan, where people who passed through here or Göttingen or Munich or Cambridge sort of took knowledge back with them and then established the respective disciplines in their home countries. And many, many people from all over the world sort of hold Bohr in very high regard because he's seen sort of as the nucleus or like the initial thing sort of that kickstarted the development of modern science in their countries. Copenhagen this way became a center of modern physics. In 1929, conferences started to take place in this very room, and they assembled the crème de la crème of modern physics. The conferences are so cool because they didn't have abstracts, they didn't have a set program, they just invited people, not for 1, but for 2 weeks to be here, usually in the spring and then later on in the fall. And they would just start by talking about the newest stuff in physics. And then Bohr would at some point out to Heisenberg or somebody else, you know what, why don't you tell us tonight about the neutrino or something like that? And then Heisenberg would read up on that and come back later and give a half-hour introduction, maybe doing some calculations, and then it would start discussing. So there was no prior plan. People would, of course, report about the stuff they had been doing during the past year and so on, but they didn't come with slides or with a manuscript or something. It was made up as they went, which is quite impressive. Also, of course, it's only something you can do if you're not that many people worldwide, right? I'll show you some pictures of these conferences in a moment, but now let me quickly focus on one particular young boy, and that's Heisenberg. You can see him here. That's the very first picture we have of the two men. They had already met in 1922, where Heisenberg had asked a really, really good question during a lecture that Bohr gave, and he was like 21 years old or something like that at the time. Bohr hadn't met him before, but Bohr then invited him on a walk after the lecture, which was so almost like getting knighted by Niels Bohr, right? Actually, if you watch the Oppenheimer movie, this story is being told about Oppenheimer. That's not true. It was Heisenberg who asked the one intelligent question in Bohr's lecture, not Oppenheimer. There were long stays Heisenberg had in Copenhagen in 1924 to 1927. And in 1924, he started to attempt to sharpen Bohr's correspondence principle. I'm almost certain you've heard of the correspondence principle. Nowadays, we just say in the limit of high quantum numbers, quantum mechanics reduces to classical physics or classical mechanics. They actually use it the opposite way. They said, what do we have to do to equations of classical physics so that they turn into quantum theoretical equations? And they had found ways to do so using the quantum condition, circular or like phase integral P dq equals n times h or something like that. They could do that in some cases, for instance, the hydrogen atom, to explain the Stark effect or the Zeeman effect, but it failed dramatically in almost all other cases. So sharpening the correspondence principle means let's find a recipe that turns any classical equation you throw at it into a quantum equation, sort of automatically, of course, with a little bit of work, but automatically. That was what they were after. And that's actually what quantum mechanics is. Matrix mechanics, as we now call it, Heisenberg's version of quantum mechanics that he came up with in 1925, is exactly that, a sharpened correspondence principle. It is a prescription for what to do with Newton's equations of motion, if you will, to turn them into quantum equations, which are, as we now know, equivalent to the Schrödinger equation, so non-relativistic quantum mechanical equations. Of course, they didn't know that Schrödinger came later than Heisenberg. He was 23 years old, but I mean, there's other cases of people who made big contributions to physics at older ages. If you're already past that age, don't be too worried. Or you just become a historian of physics. That's also a possibility. In 1932, Heisenberg would get the Nobel Prize, and this is a famous quote. Actually, he never wrote it himself. It's quoted after a historian of science, Armin Hermann. But this encapsulates a bit the world of theoretical physics at the time. Heisenberg would spend time at all three places, Munich, Göttingen, and Copenhagen, says, from Sommerfeld in Munich, I learned optimism, from the Göttingen people, mathematics, and from Bohr, physics. In March 1927, Heisenberg submitted a paper to Zeitschrift für Physik in which he formulated his famous uncertainty relation. So that's well after he developed quantum mechanics. It's sort of actually as part of his attempts to make sense of quantum mechanics and to show that his approach actually was superior to Schrödinger's. Heisenberg sent off this paper without Bohr's blessing while Bohr was on a skiing trip in Norway. When Bohr returned, he was furious. Actually, it is being said that Heisenberg started crying after Bohr put him under pressure. He certainly was not amused, Bohr, about this unilateral move to just publish a paper on the foundations of quantum mechanics without asking his supervisor about it. And then he forced Heisenberg to add a note added in proof to the manuscript, where Heisenberg basically takes back half of what he's saying in the main text of the manuscript. For instance, Bohr was not convinced that you should give up on classical notions like position and momentum or trajectories, whereas Heisenberg had argued that he just wants to get rid of them. Let's get rid of anything that we cannot observe. So trajectories, position, momentum of subatomic particles, we cannot use in our theory. Bohr was against that. And actually, I would say to some extent, he was proven right. We still need these notions if we want to do physics, right? Even though they're classical notions and we cannot observe them. In the fall of 27, probably pushed by Heisenberg to it, he presented his own view, Bohr, which is complementarity. It's the complementarity interpretation, as he calls it, of quantum physics, which you might have heard of, which sort of argues that we have different perspectives on particles, if you will, on entities in quantum mechanics. For instance, that they are particles or waves, and that all these perspectives taken together actually form the whole about the entities of quantum mechanics. Not one single perspective on its own can explain physics, and that we always sort of need to take all these perspectives into account. Yes, so this is something published in 1930, and is actually the title of my talk, The Copenhagen Spirit, right? This is the first time we find that in print. I'm gonna read that quote from you. It's from the introduction to that book by Heisenberg. On the whole, the book contains nothing that is not to be found in previous publications, particularly in the investigations of Bohr. The purpose of the book seems to be, to me, to be fulfilled if it contributes somewhat to the diffusion of the Copenhagener Geist der Quantentheorie, if I may so express myself, the Copenhagen spirit of quantum theory, which has directed the entire development of modern atomic physics. So what is this Copenhagen spirit? Well, maybe it's just Bohr himself. Is he the spiritus rector of this place and of the development of quantum physics? Is that what Heisenberg is referring to? That's Bohr in his office over there in the villa building. Or is it a specific style of doing physics, this sort of principled approach, for instance, sharpening the correspondence principle, what I just told you about, the way to quantum mechanics being, let's find a recipe that works at all times. Here you see him with Heisenberg and Pauli discussing in the 30s. It could also be a specific interpretation of quantum mechanics, this Copenhagen spirit, right? Maybe it's complementarity, what we now call the Copenhagen interpretation that I mentioned in the very beginning of the talk. Or is it maybe a specific way of interacting with students, postdocs, and colleagues? That's again in this room here, Blackboard was a bit smaller back then, and this one was a bit smaller, but otherwise it's the same room, and you see Bohr having fun with students who are sitting on the desk. That's unheard of at places like Munich or Göttingen, right? Which were very stiff, where you would use Herr Doktor, Herr Geheimrat, Herr Professor, and so on. Here they had fun, they played ping pong with their books in the library, things like that, right? So is that maybe the Copenhagen spirit? Well, for the purpose of this talk, and I would say also more generally, it's all of the above. It's this concoction of factors. You have a genius, let's call him once a genius during this talk, Niels Bohr. And he's not just a genius physics-wise, he's also a genius in interpersonal relations. He knows how to deal with many different characters and how to bring them together and to bring them to fulfill something great. It's a specific style of doing physics, a specific interpretation of physics, actually the willingness to think philosophically and deeply about what you're doing as a physicist. It's a specific way of interacting, having fun. I told you about these conferences and so on. So it's the entirety. And actually, all this has been copied many, many times throughout the world. So you're maybe used to some of these things without really knowing that they come from here. If you studied at an American university or something like that, the colloquia that you're participating in as a PhD student or something, they're run very much in the same vein they've been run here. But here they have actually been run like that for the first time. Or little footnote, it's actually Ernest Rutherford's lab in Manchester where some of these practices stem from. But sort of Bohr had it from Rutherford. All the Americans and people from around the world learned it here in Copenhagen, took it back with them to the US and other places. And after World War II, they actually exported it. And we would think of it as sort of American practices in physics back to places like Germany, France, Italy, and so on, which have sort of adopted to how physics was being done in the US. Little did we know that that actually comes from here. So that's pretty amazing. Here you can see how quickly it spread. This is a letter that George Gamow sent to Bohr in 1935, where he reports about the very first conference in the Copenhagen spirit in the US. And you don't have to read that, but like to those of you who know Danish, this is very funny Danish. It's like you can understand it, but it's a Russian who's used to speaking English, writing in Danish. This is George Gamow's drawings for the 10th anniversary of the Institute. Niels Bohr is Mickey Mouse. The first Mickey Mouse movie had just come out. So that was, I don't know, maybe if we did it this year, we would have to use Barbie instead. And you can see the Institute. You can see many, many of the things that are happening in those years. Let's switch to the second slide on that. For instance, you can see this is just a single slit, but still, that's exactly what we had in the last talk. The famous slit experiment, and many, many other things. I'm not getting into the details, but it's sort of a jocular way of looking at what happened at the Institute during those years. These are pictures from these conferences. This is the very first one, still rather small. You can see Niels Bohr is sitting where Markus is sitting. And that was his, or the other way. One should probably say Markus is sitting where Niels Bohr used to sit, right? That's the right way of saying it. Then you can basically find out yourselves where you're sitting. I don't know, this is Kramers, this is Ehrenfest, this is Gamow, and I could go on here. Pauli is hidden in the back. This is Pauli, and so on. This is the more famous 1930 conference, and here you basically know everyone in the audience: Oskar Klein, Niels Bohr, Werner Heisenberg, Wolfgang Pauli, George Gamow, Lev Landau, Kramers. You have Peierls sitting here. And now just for the Danes, because the others won't know him, this is actually Piet Hein, who studied here at the time. He's like known as a poet and so on, nothing to do with physics in the Danish mind. All right, he's the only one not wearing a tie, by the way. That's a bigger one, even in 36, with Lise Meitner in the front row, and Max Born and James Franck, and again, Ehrenfest and a few others. John von Neumann here. Edward Teller is also somewhere, and several other people. Woo. All right. What happened in the 30s here? Well, first and foremost, many emigre scientists from Europe joined the Institute. Bohr redirected research at this place from atomic physics, which basically had been solved, towards nuclear physics and also experimental biology. The latter, mostly because money was to be gotten for experimental biology. He went on international trips, for instance, to the Soviet Union, to the US, to Japan and China. He had long debates with philosophers about the unity of science and the interpretation of quantum mechanics. He came up with the compound nucleus model, which is sort of a liquid drop model of the nucleus, an alternative to the single particle quantum well model they had been using so far, where you sort of tunnel out the infinite quantum well. Then in 1939, right after Hahn and Strassmann and Meitner and Frisch had discovered fission, nuclear fission, they actually managed to explain it on the basis of this model. Bohr got big machines to be built here. Look, this is Bohr and Hevesy standing in front of their generator. They have like a Van de Graaff generator and a Cockcroft Walton accelerator attached to it. Copenhagen became basically what CERN is now, the European Center for doing experiments in nuclear physics and particle physics. It lasted about 4 years or 5, and then all was over. I'll get to that in a second. So the bottom line is, during the interwar years, Niels Bohr's Institute became the worldwide center of modern physics in both theory and experiment, period. No better place to go to than Copenhagen. Well, and then came the rupture. In April 1940, on the 9th of April, the Germans occupied Denmark. They were actually interested in Norway, but sort of on the way, they also captured Denmark. Left just a small garrison here, but still. All right, that's the end of sort of the happy phase in Bohr's life. Now start the hard years, and let's see. I'm not sure I get to the end of my talk, but you'll give me notice if it's getting too long, right? So here's a picture. That's the main entrance of the Institute that you've been going through every morning. In 1943 or 1944, there's a German soldier stationed before it. This is actually the leaflet the Germans dropped from airplanes on the day of the occupation. It's actually in Norwegian, which shows how much respect they had for the Danes when they were invading their country. You might have seen this building. It's that way, about 100 meters. It's the Freemason building. It was also the headquarters for the Danish SS Corps that was stationed in Denmark. It's Danish people who had joined the SS, joined the Nazi SS organization, and called themselves Schalburg Corps. And they were stationed there from 1943 to 1945 in the immediate vicinity of this institute. This is how Stefan Rosenthal, Bohr's assistant at the time, explains how things were during the occupation. For a long time, Bohr succeeded in keeping the work going, even if events made dramatic claims on time, strength, and nerves. The staff shrank in numbers, no foreign visitors could come, and the few who remained gradually left the country. But mainly it was the pressure of world events which weighed heavily on people's minds. Wherever Bohr was, at home, at the Institute, or with friends, he listened to every single news bulletin, both from Denmark and from British radio. The general war situation, what was happening closer at hand, occupied his thoughts and gave rise to long conversations and speculations about the progress of the war. So again, this is the main entrance of the Institute. We're in this building, right? Every morning you go in there through that door. There is a famous visit by Heisenberg in 1941 that you might have heard of, which I should mention in this talk. Heisenberg comes to Copenhagen for a talk in the German Cultural Institute, actually talk about astrophysics, not quantum physics or nuclear physics, and then also meets Bohr. And this meeting is a matter of controversy ever since, both among historians, but also among the actors themselves, Bohr and Heisenberg, first and foremost. There was a minimum consensus. Heisenberg mentioned the German bomb project, German uranium project, and was overall very optimistic about an eventual German victory in World War II. And both are startled by their conversation. But what really happened, we don't know. So there's two conflicting accounts. One is Heisenberg's, one is Bohr's. First, let's hear Heisenberg's. Heisenberg was driven by moral considerations, wanted to inform Bohr about the peaceful nature of the German uranium project. They just wanted to build a reactor, not a bomb, and thus wanted to inform the Allies so that they don't start building a bomb, maybe, or even sabotage the Nazi war effort. Bohr turned Heisenberg away, which left the latter in despair. That's the version that Heisenberg tells to Robert Jung in 1957. Robert Jung writes a book called Brighter Than Thousand Suns about the German bomb project. When Niels Bohr reads that, he says, wait a moment, that's not what happened, and starts drafting several letters to Heisenberg, which he never sends. We have them at the archive, and you can look at them on our webpage. So if you go to nbarchive.dk collections, then you can read all these letters. We have them translated into English also. And in these letters, he gives a completely different version, and that's this one. Heisenberg was driven by a belief in German victory, right? That's 41, summer 41. It's before Stalingrad. It's before things went sour for the Germans. And he said, come on, why are you still holding out? Join us. He wanted to enlist Bohr and other scientists, actually, here in Denmark in the efforts to build an atomic bomb to win the war, or to at least become really powerful after the war if you don't use it during the war. Bohr was horrified by the meeting and the betrayal of his trust and friendship, and by the very notion that Heisenberg could even think of him joining the German war effort. That was so remote to him that he would ever do something like that, that he expected Heisenberg to know that he would not join the German effort. There is a theater play about all of this and a movie. So the theater play is by Michael Frayn. The movie is, I now forgot the name of the main actor, but it's James Bond, right? So the guy currently playing James Bond, who plays Niels Bohr in that movie. In the fall of 1943, Niels Bohr had to flee, and that is because the relations between the Danish civilian government and the German occupiers soured dramatically within very short time, because Stalingrad had happened, and the Danes all of a sudden started to sabotage, to kill German soldiers on the streets and so on, because they wanted to drive the Germans out. They were optimistic that the war was about to be over in mid-43, in the summer of 43, and it turns out they were way too optimistic because it would still go on for 1.5 years. But that meant that the Germans actually took over, and that also meant that they would use all the rules that were in place in all other occupied countries, including the persecution of Jews, the killing of Jews, the deportation and killing of Jews. But the Danish Jews, many Danish Jews heard about this through channels that actually involved the German embassy. So some Germans warned. Many people believe that some Germans warned some Jewish Danish people, and that led to them actually making plans very rapidly to leave the country. And Niels Bohr and many others left the country by fishing boat across the Øresund, which is this strip of water between Denmark and Sweden, just a few kilometers wide, at night, secretly evading patrol boats and also sort of German soldiers at the shore. And all of them, like all of the Bohr family, actually luckily managed to escape in late September, early October 1943. This is actually a SS police regiment order banning all civilians from this institute. So for a while, the Germans also took control of this institute. There's many stories about that as well. And here you see the only picture we have from Niels Bohr at Los Alamos, the Manhattan Project. You wouldn't think of somebody skiing when you think about Los Alamos, because it's in the New Mexican desert. But of course, there's also snow there in the winter times. That's the only picture we have from Bohr's time in the US during World War II. This is a much later picture of Bohr and J. Robert Oppenheimer, taken in 1958 when Oppenheimer was visiting Copenhagen. They became really good friends, had already become friends before the war, and respected the hell out of one another. I could now give an entire lecture on just their personal relationship and on Bohr's involvement in the Manhattan Project and so on. I'll leave it to the questions because I want to quickly get. Yeah. Yes, but he was not here for long. He probably visited, but they met in Cambridge actually. So the story goes, Oppenheimer went when he was 17 years old to 2 lectures that Bohr was giving at Harvard in 1923. And maybe he was 18 years old, but sort of very young, still before even studying physics, right? And he was completely amazed by Bohr. And that influenced him very much to even becoming a theoretical physicist. And they met in person for the first time in Ernest Rutherford's lab at Cambridge in 1926, when Bohr was visiting because he had been made a member of the Royal Society, a foreign member of the Royal Society. And there the story goes, okay, I'll tell you that anecdote, is beautiful. Niels Bohr, having just met that guy, Oppenheimer, who was, I don't know, how old was he in 26? He was born in 04, so he was 22. And Rutherford had told, this is a really promising young student. Bohr said, oh, nice to meet you. So tell me about your work. And then Oppenheimer said, oh, I'm in trouble. I have problems I can't figure out. And then Bohr said, well, are these problems mathematical or are they physical? And and Oppenheimer couldn't answer. He didn't know. Are these mathematical problems or physical problems? And that influenced him apparently very, very much, because he found out that he's actually not the type of physicist, of theoretical physicist, who churns out the mathematics and then thinks about the interpretation, but that he much rather, like Bohr, is somebody who thinks about the problem for a long time and then does the necessary mathematics when he already sees the solution. Right? And I think if you think about yourself, there is physicists who are very much verbal, who like to talk about things, who like to sort of visualize things, who like to understand things. And then if they have to, they do the mathematics. And there's other types of physicists, so it's the 2 extremes, of course, of a continuous spectrum. But there's, on the other hand, there's the people who really enjoy the mathematical part and the sort of going through equations and the formalism and so on. And then sometimes forget about the physical interpretation because the mathematics in itself is very beautiful, right? So Bohr and Oppenheimer were at the other end of the spectrum. They were the verbal ones who actually didn't care so much about the mathematics. They did it, they were good at it, but they didn't like it. All right, plenty more to say about Oppenheimer. I'm not doing that. Now we're getting to after the war, and the question is, do I skip that?
If you, maybe for a few more minutes.
Yeah, okay. So just show you pictures of him coming back to this institute, of course, by bike, not by car or anything else. That's in August 45. He was only allowed back to Denmark after Hiroshima and Nagasaki. So that's why he came back in August of 45 and not earlier. Denmark was liberated in April, or early May, actually. Post-war physics had changed completely. The center of gravity of physics had moved to mostly the US, but also to the Soviet Union to some extent. And the biggest research interest after the war was, of course, nuclear physics. There were many, many more physicists than before the war. There was much more money in play. Groups had grown from like 5 people to 200 people and so on. So really, the nature of physical research had changed dramatically. So how do you stay relevant in a world that all of a sudden has huge amounts of money, huge experiments, many physicists and so on, and all of them not in Europe anymore, but in the US or in the Soviet Union? Well, you need to redirect your research, and you need to do that cleverly. And the person doing that, I think I'm getting ahead of myself, first and foremost was Niels Bohr, and then there's another person coming very soon. I don't want to ruin my punchline for another slide. Bohr tried to get CERN to Copenhagen. That failed. As a consolation prize, he actually got the CERN theory group to be stationed here for 5 years. But when they found out that actually having the theorists split apart from the experimentalists at Geneva doesn't make sense, they moved the theory group to Geneva, and then they created something called Nordita, the Nordic Institute for Theoretical Atomic Physics here. And also through the Atoms for Peace program the US ran, they got a swimming pool reactor for Riseux and established a nuclear research center there. But the bottom line is, despite all efforts during the post-war decades, the center of gravity of modern physics had moved away for good from Copenhagen to elsewhere, right? It's not the center of the world anymore when it comes to physics. Well, is that the end of the story? Is that the death of the Copenhagen spirit? Should we all mourn? My answer is no. Read this quote. It's about the 60s. This is Jerry Brown, a famous many-body nuclear physicist. I moved to Copenhagen in the summer of 1960. Copenhagen was at its zenith in nuclear physics, with the Bohr-Modelson collective model explaining more and more nuclear phenomena. Bohr and Modelson had built up the extremely successful Copenhagen School in nuclear physics. The more famous pre-war Copenhagen School still permeated the buildings of the Bohr Institute and Nordita. Adherents of the Bohr-Modelson School came from all over to revel, experimentalists to fit the data. So did I tell you something wrong just now? Well, note this. This is not Niels Bohr. This is Joas Bohr, his son. So the person chiefly responsible for turning things around here and for making Copenhagen relevant again is actually Joas Bohr, his son. You can see him here lighting the pipe of his father. So this is Joas and this is Niels. Or is it a camera they're looking at? Maybe it's a camera they're looking at. So he played a central role, and actually now I'm gonna detach myself from my slides and just tell you the story rather quickly. He discovered if you do low energy nuclear physics, that is nuclear structure physics, experiments are easy. You use, I don't know, microwave spectroscopy and things like that. You don't need huge labs, you don't need accelerators or anything like that. So you can do experiments here, plus doing the theory is not costly either. You can get the literature and the measurements from all over the world and just try to figure out how nuclei are structured. And actually, Joas Bohr, together with Ben Modelson, who soon would join him, then came up with his own model of the nucleus, the so-called collective model of the nucleus, which brought together two different strands of development. On the one hand, you have the independent particle, or you often call it shell model of the nucleus, which is basically an analogy to how the atom is put up. So you sort nucleons into shells and make up the nucleus that way. And on the other hand, you have the strong interaction compound nucleus model, or you could also call it the liquid drop model, that accounted for some other things, but they sort of didn't connect well. Victor Weisskopf had the idea, maybe those two models do not compete, but rather complement each other in the very sense of Bohr's complementarity, right? And this is the research program that Joas Bohr, Bohr's son, actually successfully followed. Let's just look at the equation here. The main idea is you have a Hamiltonian, which consists of a particle Hamiltonian, a collective Hamiltonian with collective variables, say, think of plasma oscillations of the nuclear matter or something like that. And then you have a coupling term between the two, which is basically just the original Hamiltonian minus these two. And this is a small thing. You can do perturbation theory with that as your parameter, and it works. So you can calculate many, many things that you couldn't calculate before in the nucleus. And this made Copenhagen into a central place, so central that for Niels Bohr's 70th birthday in 1955, they had a mock form for future articles in all of nuclear physics, which had most things already filled out. Like, it always had unified model in the title. It always is about interacting nucleons. You have the Hamiltonian, which you can see here, collective motion and individual particle motion. And the references are almost always, at least the first two, in the Danish Physics and Mathematics Communications, which was the journal they were mostly using. So this is how they imagined the future of nuclear physics to look like. Copenhagen really became a worldwide center. Here you see a conference in the 50s. In this room, again, here's a nice quote. Copenhagen is the mecca of all physicists. Every American nuclear structure physicist of any standing must have spent a year at that place. That's Vicky Weisskopf in 1966. And here's an even nicer quote, very Cold War-like. If a Martian were trying to degrade mankind's ability to make progress in nuclear structure physics to the maximum extent and had only one bomb in his arsenal to accomplish this purpose, he would surely drop it on Copenhagen. That's John Wheeler on the same occasion. That's the last slide. I mean, I'll summarize it in two sentences. from the mid-70s, nuclear physics was in demise. People weren't that interested any longer. Actually, they had the feeling that they would be winning the Cold War also without the help of physicists in the West. So the institute became much more like a normal physics department, especially starting in the 90s, where solid state and astrophysics and many other things were added. But in many of these areas, Copenhagen, I would claim, still checks most, if not all, of the boxes for the Copenhagen spirit. That is informality, internationalism, culture of discussion, openness. That is because of a strategy of excellence. So you choose specific areas you really want to be great in and neglect others, right? For instance, for a long time, no solid state physics was being done here because there was a conscious choice to focus on nuclear structure physics and other things. Nowadays, for instance, there's new areas where there's really a lot going on. I should mention first and foremost quantum computing, but particle physics, astroparticle physics, some areas of condensed matter and nanophysics, ice and climate, dark cosmology, and so on. So that's sort of the strategy that was followed here. That's just my conclusion. I said all that already. You see Niels Bohr on a motorcycle. That's much more interesting than what you have in text here. Here is some literature. And I'm happy to switch back to that slide in a moment. I also want to mention that if you ever feel like leaving physics and would be intrigued to do some history projects, we have plenty of them. So feel free to talk to me or email me at any point, or also if you're just interested in, I don't know, seeing some original documents or so, you would be most welcome. Thank you so much for your attention. 45 minutes, I'm sorry. I
could sit here for another hour or so, but I'm not sure if people are getting hungry. Yeah, so thanks a lot. This was a very great presentation of the history of the building, and yeah, so all the history that happened exactly here in this room. Yeah. Do we have any questions? Yeah.
Yes, thank you very much. I have a very trivial question, but you had a slide where it was Niels Bohr escaping on this boat.
Yeah.
1943 or something like that. Do we know which harbor?
Yeah, very much so. He was living in Valby in the Carlsberg Honorary Mansion. That's actually the mansion that belonged to the founder of Carlsberg Breweries. That's where Niels Bohr was living. And he would go by foot to an area in what is now called the Southern Harbor, Sydhavn, and hide there until early in the morning of the 30th of September. They would board a ship which would take them to the trawler they eventually would then go to Sweden with. So it was really a major operation. They got wet because they had to hide from some German foot soldiers who were patrolling in the area in a hole filled with mud and water and rain and so on. So it was really like you could make a good movie out of that, right? But of course they were scared to death.
Thank you very much.
But I could point out to you on a map where exactly it looks different today. It used to be sort of a landfill area where they would drop like garbage from construction sites and so on. And now it's a beautiful park and there's sheep and alpaca there. So if you've ever seen an alpaca in Copenhagen, that's where they fled.
Okay. Yeah.
I just have one quick question. So you showed a picture of Einstein with Niels Bohr here, and was Einstein here often? Traveling here?
I did show a picture of Einstein and Bohr.
I think, yeah.
Okay.
Just one picture. Yeah.
Let's try and find it. It's probably among those, right?
Yeah, 20s somewhere. Yeah, this
is actually not taken here. So that's why I'm confused. This is taken in Leiden in Ehrenfest's apartment in the 20s. It's probably soon after they first met. They met first in 1920. Einstein was in Copenhagen twice, never, as far as we know, at this institute, because he was here before the institute was opened. And once he was here just traveling sort of from Sweden back home and was just here for 5 or 6 hours. And we know that he visited Niels Bohr's home and got coffee from Niels Bohr's mother and so on. So they probably weren't here either. But they met, of course, many, many times elsewhere. So later in their lives, Bohr would be at Princeton very much, where Einstein was. But also before, they would meet at the Solvay conferences and other places. So they were good friends. They actually loved to discuss with one another about the foundations of quantum physics. It's not true that Einstein hated quantum physics, not at all. He just hated the interpretation that Bohr had given quantum physics and tried to sort of find ways of getting rid of that, but he was not against quantum physics. He's actually one of the biggest contributors to quantum physics. So forget about Einstein being an enemy of quantum physics. That's an important message. And I could tell you, I could go on. There's great anecdotes about the two, but maybe
Thanks.
another time. Yeah.
Okay. Yeah.
So the plan is that you also
yeah.
get to see Niels Bohr's historic office. You already saw this place. I don't have to introduce that to you. And let's do a quick head count.
So we have about 25 people.
Yeah, we're at the brink of this being uncomfortable because it's a small office. Should we try? Worst case scenario is that some of you have to wait outside and we do 2 quick tours. I think we can probably, I already talked so long, we can probably do it in 10 minutes or something like that. Is that a good idea?
So maybe we do that now. So so lunch is already here, but I mean, it's bookable, so they can wait. And of course, you're also welcome to join us after the
one
tour
more
if you want.
question.
Yeah. Oh.
We just go back to the picture with Niels on the bike.
Okay. You can probably also find these pictures on the archive.
Yeah, not all.
Not
you can write to me and then you'll get them. Yes.
Okay.
This one, you mean?
No, on the bike.
Oh, the motorbike. Okay.
Ah.
Yeah.
This one.
At the very end,
The
you had it.
motorbike.
With
That's my
Gamos,
conclusion slide.
Yeah.
All right.
So I would say, so let's thank Christian again, but of course,
Thank you.